center of mass, and I think I did 2 questions related to center of mass topic. One is a problem involving uniform mass distribution, and another is a problem involving non-uniform mass distribution. So today we will do further problems in the topic of center of mass. Okay, so what are the various problems that are possible in center of mass topic? One, of course, is find the center of mass of some unique object having some sort of a uniform mass distribution. ठीक है, उसके लिए you will have to figure out some kind of a area element or volume element and integrate appropriately in the right coordinate system with respect to the right limits. The second kind of question possible is you are given a known standard system where you have a non-uniform mass density. वहाँ पे भी you will have to take some area element or line element or volume element and integrate appropriately by taking into account the density as a function of that particular coordinate. Other questions that are possible is questions related to some kind of a scooped mass system. So questions in which the object can be created by 2 or more objects, or object can be created from a previous object by taking some kind of a mass out of that original system. ठीक है, अगर पिछले क्लास में कोई डाउट नहीं है तो आई विल कंटिन्यू टू दिस पर्टिकुलर क्वेश्चन. ठीक है, स्टार्ट करते हैं. ऑलराइट, सो आई विल कॉल दिस एज प्रॉब्लम्स इन्वॉल्विंग scooped objects. Okay, so problems involving scooped objects में there are 2 kinds of problems that you get: calculations related to center of mass as well as calculations related to moment of inertia. Moment of inertia we will do when we study rotational motion. Abhi we are focusing on center of mass only. So problems involving center of mass of a scooped or deformed object. Okay, now this kind of a problem solving is only possible if the mass distribution is uniform. So this is the method that I'm going to show is not valid for non-uniform mass distribution. Not valid for non-uniform mass distribution. So what we will do is, if usually what happens is that if there are 2 masses m1 and m2, the center of mass is given as m1 r1 plus m2 r2 upon m1 plus m2. Okay, if there are 2 masses whose center of mass we are interested in finding, we usually use this kind of an expression for 2 masses m1 and m2. But what if we consider a new kind of a system where a certain amount of mass has been taken out of the original system, scooped out? Okay, so for example आपके पास एक स्फीयर है, ठीक है, और उस स्फीयर में से मैं एक पर्टिकुलर कॉनिकल शेप्ड मास निकाल लेता हूं. सो आई टेक इट आउट ऑफ द सिस्टम. ओके, आई टेक इट आउट. सो द क्वेश्चन इज व्हाट इज गोइंग टू बी द सेंटर ऑफ मास ऑफ द रिमेनिंग सिस्टम. तो ऐसे सिचुएशन में हम क्या करेंगे? What we will do is we will assume that the second mass has negative mass density. That's it. The moment we do that, everything else will fall into place and we will be able to do the calculations as usual. So if mass m1 has been, or if mass m2 has been scooped out of original mass m1, then we simply consider m2 to have negative mass density. Okay, so what you do is you take center of mass is equal to m1 r1 plus minus m2 r2 upon m1 plus minus m2. That's it. That's the only difference here. Okay, so if you have two masses which are combined, you want to find out the center of mass of the overall system, then you add them up. But if you have one original mass and then you take a small amount of mass out of the original mass, so the final mass system is less, in that system you simply consider the scooped mass to have negative mass density and you perform the calculations as usual. You should get the correct answer in that kind of a situation. Okay, so यहाँ पे you have to be very careful that we are dealing with m1 mass of original unscooped object and m2 mass of scoop portion. Okay, और कुछ नहीं है. There is no other deep concept involved. If you can simply consider them as two different bodies, one having positive mass density, the other having negative mass density, then questions involving some sort of a deformation becomes very easy. So I'll give you a question, okay? Simple question देता हूँ, आप इसको try कीजिए. This is a question from JAM. JAM में इस तरह के questions common है. You will find questions like this in JAM. I hope you have noted this down. Okay. So this is a question from JAM 2015. A spherical hole of diameter r has been scooped out of a solid sphere of uniform mass density and radius r. तो ये आपका r हो गया और ये कितना हुआ r/2. The hole is centered at xy0 is equal to 0, 0, r/2 as shown in the figure. What is the center of mass of the overall system? Try करना चाहोगे? What is the center of mass of the final configuration? Yes, please try. So you had a sphere, and from that sphere, a smaller sphere was taken out. So the original sphere has a radius of r, and the sphere that is taken out has a radius of r/2 or diameter of r. So what is going to be the final center of mass of this final configuration? Please check and give me the answer. Try. These kinds of questions are very common, especially in exams like JAM. I've mentioned the mass and the void here, okay? All right, let me check the answers. Kashan, your answer is correct. Karthik, it is not correct. Check again. See, in questions like these, you consider the original mass and the scoop mass as two different bodies. The only difference is that you consider the scoop mass to have negative mass density because that is acting as taking out of the system, right? It is not adding to the system. It is being taken out of the system. That's it. If you make this small change, you will be able to solve these kinds of questions. Think of the original mass as M1 and the scoop mass as minus M2. That's it. That's it. बाकी कैलकुलेशन सिमिलर है. Bamdev and Sampurnananda, correct answer. Yashwant also correct answer. Very good. मैं स्टार्ट कर देता हूँ. Keep track of your various physical quantities. यहाँ पे mass mention नहीं है, but we can sort of decide on our own. सबसे पहले तो ये बताइए, because this is a three-dimensional object, the center of mass will have a coordinate in x axis, y axis, z axis. So are any one of the coordinates going to be 0? The original system had center of mass at 0, 0, 0. But for the new system, can you make a guess कि y
Yes,
क्या
sir.
होगा?
0, 0 r by 2. 0, 0 r by 2.
So x axis का coordinate system, x axis में center of mass 0 ही रहेगा. Why? Because if you look at the overall mass distribution, the mass distribution is symmetric with respect to the origin of the x-axis. So this will still remain 0. If you look at the mass distribution with respect to the y-axis, then the entire mass distribution is symmetric with respect to the y0 of the y-axis. So ये भी 0 ही रहेगा. The only coordinate which is going to be non-zero is the z coordinate. ये हमें क्या है नहीं मालूम, right? It is a z coordinate that's going to experience some small change, and that is what I want to calculate. I don't want to calculate x and y. I simply want to calculate z. Okay.
Sir, how can you say that it is symmetric along x-axis and y-axis? I can't see it because there is a hole. Why is the symmetry?
The mass distribution is uniform if you look at it from the origin of the x-axis, isn't it? Or symmetric, don't you think? I mean, मैं इसको कैसे आप विजुअलाइज, आपको थोड़ा विजुअलाइज करना पड़ेगा. ये आपके पास एक स्फीयर है, ठीक है? अगर मैं यहाँ से एक एक्स एक्सिस ड्रॉ कर देता हूँ, तो ये बताइए अभी फॉर द टाइम बीइंग, is the mass distribution symmetric with respect to the origin of the x-axis?
Yes, it is.
It is. Fine. तो अब मुझे एक बात बताइए. I'm going to make some changes to this sphere and you tell me whether it affects the center of mass along the x-axis. ठीक है? If I make a hole here, would it affect the center of mass along the x-axis?
No.
Why not? x-axis में तो फर्क पड़ गया ना. Along the x-axis, the mass distribution is not, it has been shifted slightly, don't you think? इधर mass ज़्यादा हो गया अभी.
Oh, yes, 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 it is.
इस तरफ थोड़ा कम हो गया. आप उस point of view से देखो ना.
Okay. हाँ.
Are you seeing? But अगर x-axis के अगर मैं इधर पे होल्ड करूँ तो is that going to affect the x coordinate of the center of mass? x coordinate में फर्क नहीं पड़ेगा. z coordinate में फर्क पड़ेगा, लेकिन x coordinate में फर्क नहीं पड़ेगा. still it is not clear. How do I explain it?
सर बट
थोड़ा
अगर
सा
आप थोड़ा सा राइट में करेंगे तो फिर एक्स पे भी फर्क पड़ेगा ना। अभी आपने बिल्कुल जो जीरो है ओरिजिन है उसके ऊपर जो होल किया है, अगर आप थोड़ा सा राइट या लेफ्ट में करेंगे तब तो पड़ेगा ना सर।
हाँ तब पड़ेगा। देखिए ये जो मास है ना, इसका एक्स कोऑर्डिनेट क्या है, 0 है ना। यस,
Yes.
तो दैट इज नॉट गोइंग टू अफेक्ट द ओवरऑल सेंटर ऑफ मास एक्स कोऑर्डिनेट। लेकिन अगर होल यहां पे होता तो इसका जो एक्स कोऑर्डिनेट 0 नहीं होता, तो देन दैट इज गोइंग टू अफेक्ट द overall x coordinate of the center of mass of the overall system. Is it making sense?
Yeah, it makes. Yes.
Yeah, so because the overall center of mass is derived from, let's suppose मैं अगर center of mass का calculation करता हूँ तो x axis के लिए ये क्या होगा, m1 x1 plus m2 x2 upon m1 plus m2, right? So the scoop mass है, scoop mass का जो x coordinate क्या है, 0 है, so that is not going to affect anything.
It is 0 and it is symmetric about the in shape. That's why it is not making difference.
Yeah, same for y axis. The only difference is going to happen for the z coordinate. Okay.
Yeah.
All right. So if we make the calculations, let's suppose मैं थोड़ा सा अच्छे से define कर देता हूँ. M1 is the original mass of sphere of radius r. M2 is the scooped mass of sphere of radius r by 2. Now the question is, masses are not really given in the question, right? The only thing I know is that it's a uniform mass distribution. So if it is a uniform mass distribution, I can assume that it has a uniform mass density, right? And the mass density will be same for the scooped mass. It will be same for the original mass as well as the final configuration. So what is M1? M1 is equal to mass density times volume, right? So what is the volume? 4 by 3 pi r cube. This is the original mass. So 4 rho pi r cube upon 3. What is the scooped mass? Again, density times volume of the scooped object, 4 by 3 pi r upon 2 cube. So this comes out to be 2 into 2, 4 into 2, 8. So 6. So rho pi r cube upon 6. Okay. So now what I want to do is I simply want to calculate what is going to be ZCM. So ZCM is equal to M1 Z1 plus minus M2 Z2 upon M1 plus minus M2. अगर M1 minus M2 हम calculate करेंगे तो this is going to become rho pi r cube 4 upon 3 minus 1 upon 6. So this is going to be 6, 8 minus 1, 7 upon 6. 7 upon 6 rho pi r cube. So if I substitute this here, this is going to become 6 upon 7
सर
rho pi r cube. Yes.
सर वो M2 में वो तो 6 नहीं होगा डिनोमिनेटर में।
सर
सर
8
2 का सर 2 का क्यूब 8 है, फिर इंटू 3 होके 24 आ रहा है।
तो 4 तो कैंसिल हो
ओ
गया
सॉरी,
ना,
ओ ओके सर, ठीक है ठीक है।
4 है ना ऊपर न्यूमरेटर में, 4 से 4 बचा 3 into
यस
2
सर,
6. Yeah.
यस सर, यस।
So this is going to be equal to, what is the center of mass of original system along the z axis?
0 0
Original
0।
0. So this is going to be M1 times 0 and M2 is going to be equal to rho pi r cube upon 6 times z. So what is the center of mass of the scooped volume? That is r by 2, r upon 2. That's it, done. So this is going to be equal to माइनस 6 और 6 तो हो गया कैंसिल, सो यहाँ रो पाई आर क्यूब अपॉन 7 रो पाई आर क्यूब, 6 और 6 कैंसिल इंटू आर अपॉन 2, सो ये बन जाएगा रो पाई आर क्यूब, रो पाई आर क्यूब, सो दिस इज इक्वल टू minus r upon 14. So therefore the center of mass comes out to be xcm is 0, ycm is 0, zcm is minus r upon 14. That's it. That's it, nothing else. So these kinds of questions are common, especially in exams like JAM, where you might have some kind of a deformed shape that can be, created by some original shape plus some another shape with negative mass density. And then if you just include that negative mass density, you will get the answer by following the same method of calculating center of mass. Okay? All right. Let me give you one more question, a similar question. So Monzurul, Uttam, your answers are also correct. Another question, guys. Okay. So a semicircular portion of radius r, semicircular portion of radius r is cut out from a uniform rectangular plate. What is the distance of the center of mass from the point O? Very simple question. ठीक है, आपके पास एक यूनिफॉर्म प्लेट था, सेमी सर्कल को हमने हटा दिया है वहां से, तो अब जो फाइनल कॉन्फ़िगरेशन है उसका सेंटर ऑफ मास क्या होगा फ्रॉम दिस पॉइंट? प्लीज फाइंड आउट. ट्राई. The original object was a rectangular plate and the scooped object is a semicircle. So what remains is this. What is the center of mass of this final configuration? How far is it from the point O? ओरिजिनल मास एंड स्कूप मास बताइए. Anybody? Bamdev, your answer is correct. Good. Very simple question. Two simple diagrams of a rectangular plate and a semicircle. Yashwant, correct answer. Akshay, correct answer. Sampurnananda, correct answer. If anybody is stuck at any point, आप मुझे बता सकते हो. Where are you stuck? Where is it that you are stuck?
Yes,
Are you
sir.
stuck? Huh?
सर मेरा -2r/4 माइनस का हुआ, जो मतलब इससे मैच नहीं कर रहा है.
-2r upon?
4 माइनस का.
बस, that's it. मैच नहीं कर रहा वो. So you are supposed to find the distance of the center of mass from the point O. Check करो एक बार calculations. So one point at which you might be stuck is, what is the center of mass of a semicircle? Anybody knows? Center of mass of a semicircle.
Yes, sir. 4r by
4r
3
by
pi.
3 pi.
हमने last time करा था ना?
Yes, sir.
Yes. So we did this question last time. Center of mass of a semicircle we obtained.
यस सर, यही गलती हो गई.
हाँ, यही था. सेमीसर्कल का जो सेंटर ऑफ मास होता है, that is equal to this. And you can use this 4r upon 3 pi calculation in our question here. यहाँ पे. Okay, मैं start कर देता हूँ. So if you look at this, हाँ जी.
सर एग्जाम में अगर कुछ याद नहीं हो, मतलब सेंटर ऑफ मास ऑफ सम स्पेसिफिक ऑब्जेक्ट और स्ट्रक्चर, तो क्या करें? क्योंकि वहीं पे मतलब नहीं होने की पॉसिबिलिटी है, बाकी सब तो हो जा रहा है.
तो सेमीसर्कल का सेंटर ऑफ मास निकालना तो बहुत इजी है ना.
नहीं वो तो है, बाकी कुछ जैसे जैसे कोन हो गया, सॉलिड कोन, हॉलो कोन, तो उसमें अगर गलती से भूल जाए तब तो दिक्कत आएगा ना,
तो
क्योंकि उसमें तो
थोड़ा
कैलकुलेशन हो
मुश्किल है.
जाता है.
लाइक फॉर एग्जांपल अगर कोन का है, वैसे मैंने एक टेबल दिया था लास्ट टाइम आई गेस पीडीएफ में, like these objects I have given, but वो याद रखना is much better instead of trying to derive it, because deriving the center of mass of a semicircular ring, sorry not ring, semicircular disk is easy, but solid cone is hard. I mean, it's going to consume 10 to 15 minutes of your time, which is not really worth it. You have 3 minutes per question on an average in your hands. तो ऐसे सिचुएशन में तो मैं बोलूँगा practically it's better to skip it and move forward. Practically it's better to skip it and move forward. देखिए इस बार 100 मार्क्स का जो पेपर था ना, मैं आपको बता देता हूँ. So somebody who got 50 marks was in the top 30. तो अब समझ लीजिए, giving an exam you also have to be a little smart. You don't want 100 marks. You want somewhere between 50 to 60 marks if you want to be in the top 100. है ना? तो इसलिए आपके हाथ में थोड़ा सा फ्लेक्सिबिलिटी होता है. कभी कभी हम क्या होते हैं, स्पेशली एग्जाम, ये सब चीज़ें तो हम बाद में डिस्कस करते हैं यूजुअली, बट मैं बोल देता हूँ, एग्जाम के पॉइंट ऑफ व्यू से हम सोचते हैं ना, तो वी गेट स्टक इन अ सर्टेन प्रॉब्लम एंड देन वी आर अनेबल टू मूव फॉरवर्ड. मेरे को ये करना ही है, मेरे को करना ही है, एज इफ एवरीथिंग डिपेंड्स ऑन दैट क्वेश्चन. बट ऐसा नहीं है. Your target is not really to solve every single question in the whole paper. Your target is, let's suppose you attempt 80% of the entire paper, and out of that, to what extent are you accurate? Let's suppose you are accurate 80%. So then आपका marks बन के आएगा around 60 marks out of 100. If you get around 60 marks out of 100, you are at least, based on this 2025 paper standard, in the top 25 to 30 students, all India rank. समझ लो? तो ऐसे सिचुएशन में हमें स्किप करना ही पड़ेगा, और होता है कभी कभी. आई मीन, इफ यू लुक एट द क्वेश्चन दैट वी डिड लास्ट टाइम ऑन द जो पेंडुलम वाला क्वेश्चन था ना, जो मिड पॉइंट पे स्लिप हो जाता है, यू रिमेंबर?
यस सर, वो तो
Yes, sir.
उस मोमेंट में सोचना ही तो पॉसिबल नहीं था कि उसका भी वर्क करना आएगा.
हाँ, वो बहुत ही हार्ड क्वेश्चन है. मतलब मैंने उसको नॉन कंजर्वेटिव फोर्सेस के वर्क डन से सॉल्व किया है. देयर इज अनदर ऑल्टरनेट अप्रोच विच इज कंजर्वेशन ऑफ एंगुलर मोमेंटम, विच इज काइंड ऑफ मोर ऑब्वियस एक्चुअली, बट फिर भी वो थोड़ा सा हार्ड क्वेश्चन था. तो कुछ एक दो क्वेश्चन कभी कभी प्रोफेसर्स जो है एग्जाम में इंट्रोड्यूस कर देते हैं, जो थोड़ा थोड़ा हार्ड हो जाता है. तो क्या कर सकते हैं? यू स्किप इट एंड मूव फॉरवर्ड, बिकॉज द ओवरऑल परफॉर्मेंस इज मोर इम्पॉर्टेंट देन इंडिविजुअल क्वेश्चन. बट हाँ, कोशिश करना कि एटलीस्ट जो मेन मैंने कुछ स्टैंडर्ड ऑब्जेक्ट्स दिया था ना, उनका थोड़ा सा आप आइडिया रख लो. फॉर एग्जांपल लाइक रेक्टेंगल, आइसोसेलेस ट्राइंगल, राइट एंगल ट्राइंगल, सेमी सर्कुलर रिंग, सेमी सर्कुलर डिस्क, हेमिस्फेरिकल शेल, solid hemisphere, solid cone, hollow cone. So these are some standard objects that I've given, and if you are interested, you will find, I think, most of their derivations in any standard mechanics textbook, and whatever formula sheets that you guys are maintaining for your own purposes, you write them down in your formula sheets. I think unless it is a very peculiar object, they will cover like 90% of the various objects possible. और ये जो चीज़ है, ये मोमेंट ऑफ इनर्शिया कैलकुलेशन में भी बहुत इंपॉर्टेंट होता है. बाद में जब हम रोटेशन पढ़ेंगे, वी विल सी दैट वी गेट सिमिलर सिचुएशंस फॉर मोमेंट ऑफ इनर्शिया कैलकुलेशंस एज वेल. एनीवेज, सो व्हाट इज दिस सेंटर ऑफ मास ऑफ रेक्टेंगुलर प्लेट? तो यहाँ पे सबसे पहले, शुड आई कंसिडर द वाई एक्सिस और द एक्स एक्सिस? बताइए. There is not going to be any difference in the y-axis, right? The center of mass in the y-axis is going to be 0, because the entire mass distribution is symmetric with respect to the origin of the y-axis, right? But if you look at the x-axis, then of course the x-axis is going to make a difference. So therefore we are only interested in the x-axis right now. So if we consider that this is the center O, with respect to O लिख देता हूं मैं यहाँ पे, with respect to O, what is the center of mass of the rectangular plate? बताइए. Is equal to
r/2 minus r/2 here.
minus r/2 here, because we are doing with respect to O. And the center of mass of semicircular plate, that is equal to minus 4r upon 3 pi. All right. So what is the center of mass of the final object? बस हम इनको combine कर देंगे. That's it. If we combine it, so x cm is equal to m1 x1 minus m2 x2 upon m1 minus m2. So this is equal to m1. तो m1 m2 क्या है, ये तो हमें मालूम ही नहीं. हाँ, m1 m2 के लिए हमें फिर अब वही यूनिफॉर्म मास डेंसिटी का यूज़ करना पड़ेगा. So let's suppose that surface density is given by sigma. So m1 is equal to sigma times area of the rectangular plate. So area of the rectangular plate is R times 2R. R times 2R, right? So this is equal to 2 sigma R square. And mass of the semicircular plate is sigma times pi R square by 2, half pi R square. So this is equal to half sigma pi R square. So therefore this is equal to M1 is 2 sigma R square minus 2 sigma R square times X1 is minus R upon 2 minus M2 is half sigma pi R square times X2 is minus 4R upon 3 pi, and M1 minus M2 is 2 sigma R square minus half sigma pi R square. That's it. I think if you solve it, we will get the answer. So solve करेंगे तो क्या आएगा, 2 हो गया यहाँ पे cancel. We are left with minus sigma R cube minus minus plus, और यहाँ पे pi gets cancelled. 2 से हो गया ये 2. So plus this is sigma R cube upon 3. So 1 upon 3 sigma R cube. 1 upon 3 sigma R cube, नहीं 2 by 3, sorry, 2 by 3 sigma R cube. और यहाँ पे क्या होगा, so sigma R square को अगर हम कॉमन ले लें, sigma R square कॉमन ले लेंगे, sigma R square, so we'll get 2 minus sigma R square pi by 2. So here what happens, sigma R square gets cancelled, sigma R square, तो sigma R square gets cancelled, तो बचा क्या हमारे पास, so we are left with so 2 by 3 R minus R. So 2 by 3 R minus R is minus R by 3, right? And 2 minus pi by 2. So this becomes basically 2 को बाहर निकाल देंगे, so ये आ जाएगा, हाफ बाहर निकाल देंगे तो 4 minus pi, हाफ बाहर निकाल दिया तो ये आ गया 2 minus 2 by 3 R. So this is minus 2R upon 3 4 minus pi. यही है ना आंसर, minus 2R upon 3 4 minus pi. ठीक है. So माइनस साइन इसलिए आया बिकॉज वी आर कैलकुलेटिंग विद रिस्पेक्ट टू O, बट यहाँ पे पूछा गया व्हाट इज द डिस्टेंस. सो डिस्टेंस में हमें साइन से कोई मतलब नहीं है. सो पॉइंट नंबर डी इज द करेक्ट आंसर, 2R upon 3 4 minus pi. This is the answer. Option number D is the correct answer. All right. So I think that now if you have done both these two questions, you will have a little bit of an idea how to proceed with these kinds of questions. Okay. This is a type of question where you might have some interesting object which is created by taking an original object and scooping out some other object out of it. ऐसे सिचुएशन में आपको बस इतना ही करना है कि जो स्कूप मास है उसको आप एज ए नेगेटिव मास डेंसिटी एज्यूम कर लो and then proceed with the calculations. If you do that, you should not have any difficulty getting the final answer. Okay? All right, let's move forward. So another type of question that comes in the topic of center of mass has to do with relative motion. है ना, क्या होता है कि for example, whenever you have an isolated system, in that isolated system, what ends up happening is that if one object is moving, then the overall center of mass of the system will also remain एक तरीके से constant. And because the overall center of mass of the system remains a constant, therefore the other object will also move a certain way so as to keep the center of mass of the overall system constant. So this arises simply from the Newton's first law. So let us discuss the concept first and then I'll show you this thing. So relative motion. Okay, so if you have a system of particles, that is isolated. Okay, so for example, you have a coordinate system x, y, z, and you have two system of particles m1 and m2. Okay, now let's suppose m1 and m2 together constitute an isolated system. By isolated system, I mean that there are no external forces. Internal interactions are there, but there are no external forces. Now, if we calculate the center of mass of this system, then this will simply come out to be m1r1 plus m1r2 upon m1 plus m2. All right. But if I do a time derivative, okay, on this particular system, on the center of mass, so what will I get? I will get center of mass velocity. So this is nothing but RCM, which is equal to m1 r1 dot plus m2 r2 dot upon m1 plus m2. ये velocity कितना होगा? Anybody? What is going to be VCM? Any guesses? It is going to be a constant, don't you think? Because the overall system is isolated, there are no external forces. So according to Newton's first law, if there are no external forces, the overall system will have a constant velocity along a straight line. Yes or no? मैं ओवरऑल सिस्टम की बात कर रहा हूँ, इंडिविजुअल पॉइंट मासेस की बात नहीं कर रहा हूँ. ठीक है, इस चीज को समझिए. इट्स नॉट वेरी कॉम्प्लिकेटेड. द ओवरऑल सिस्टम विल हैव अ कांस्टेंट वेलोसिटी. And in the same way, if I calculate ACM, which is equal to, ये डॉट आएगा यहाँ पे, सॉरी, RCM डबल डॉट, ये क्या होगा? M1 R1 डबल डॉट प्लस M2 R2 डबल डॉट अपॉन M1 प्लस M2. ये क्या होगा? There are no external forces. ये क्या होगा?
0.
ये 0 होगा. Which means what? It means that M1 R1 double dot is equal to minus M2 R2 double dot. So what this says is that you can have internal interactions, and because of the internal interactions, the point mass particles will have some acceleration, but the overall acceleration of the entire system is going to be equal to 0. Why? It is going to be equal to 0 because there are no external forces. So the external forces only affect the velocity of the center of mass and the acceleration of the center of mass. They play no role here otherwise. So therefore, the individual point masses will only move or will have some velocity or will have some acceleration as a result of the internal interactions only. So the external forces, if they are not present, then they are not going to affect the overall center of mass of the system. So एक और चीज, अगर if initial system was at rest, यहाँ पे v जो है कांस्टेंट है, ठीक है, बट अगर हमें पता है if initial system RCM, initial system RCM was at rest, तो क्या होगा? तो ये हो जाएगा इक्वल टू RCM RCM dot is equal to 0 हो जाएगा, right? If the initial system was at rest overall, then the center of mass is going to have 0 velocity, which simply means that m1 r1 dot is equal to minus m2 r2 dot. ठीक है, that's it. और ये जो चीज मैं आपको बता रहा हूं, that not only depends upon having no external forces, but that also depends upon no external force along a specific direction. So for example, it may be possible that there might be a force along the x-axis, but there is no force along the y-axis. तो ऐसे situation में these conclusions are going to be valid for the y coordinate. तो ये y coordinate के लिए valid होगा, x coordinate के लिए valid नहीं होगा, but y coordinate के लिए valid होगा. Are you guys understanding? So it is not just for this specific reason of no external forces, but it is also true for individual case-to-case basis for every single coordinate axis. Okay. So if there is no external force along a particular direction, the system, if it is initially at rest, the position of the center of mass of the overall system will also remain at rest. If there is no external force along a particular direction, no external force along a particular direction, and system was initially at rest, let's suppose system was initially at rest, then position of center of mass of system will also remain at rest. नहीं, ऐसा बोलना सही होगा क्या? The position of will remain at rest with respect to time, even though individual point masses may be in motion. ओके तो यहाँ पे एक और चीज है कि फॉर एग्जाम्पल अगर एफ एक्स इज इक्वल टू 0 external force, then it simply means that if fx is equal to 0, then if the original system was at rest, then the x centimeter of the center of mass will remain a constant of time. ठीक है, but ऐसा हो सकता है that fy external is not equal to 0. So if fy external is not equal to 0, then the center of mass along the y-axis will not necessarily remain a constant of motion. ठीक है, all right, चलिए, this is best understood using an example. मैं आपको एक क्वेश्चन देता हूं and that will help you understand what's happening. So again, this is a JAM type of question. तो JAM में इस तरह के क्वेश्चंस आपको मिल जाएंगे बहुत सारे. So essentially what happens is that you will have a configuration of multiple objects and there is going to be relative motion between them along a specific direction such that the center of mass in that direction will be a constant of motion because there are no forces, external forces there. Okay, there is only internal interaction. All right, let's try to understand. So a block of mass capital M is free to slide on a frictionless floor. अच्छे से इसको एक्सप्लेन कर देता हूं. तो आपके पास एक कैपिटल मास है यहाँ पे. So this is a block of mass. This is a block of mass capital M, which is free to slide on a frictionless surface on the horizontal floor. The block has a cylindrical cavity of radius r in the middle of it. So there is a cylindrical cavity of radius r. Okay. The center of mass of the block lies on the dashed line. जो dash line है वहां पे आपका center of mass है, passing through the center of cavity. Initially, the center of the block is at a horizontal distance x1 from the origin. Now a point mass particle of mass small m is released. अब क्या करते हैं? We will include a point mass particle of mass small m at A. There is negligible friction between the particle and the cavity surface when the particle reaches the point B. जब particle यहाँ पहुंचेगा, particle जब यहाँ पहुंचेगा along this direction, the block is at a distance x2. Find x2 minus x1. सबसे पहले मुझे ये बताइए आप लोग, जब ये हमारे पास सिस्टम है, ठीक है, there was a point mass particle here. जब पार्टिकल यहां से यहां तक पहुंचेगा, क्या ओवरऑल सिस्टम का डिस्प्लेसमेंट होगा या नहीं होगा, ये बताइए मुझे. फ्रिक्शनलेस सरफेस, ब्लॉक m इज स्लाइडिंग ऑन इट, उसके ऊपर एक छोटा पॉइंट मास जब इधर से उधर रोल करेगा तो क्या ओवरऑल सिस्टम आगे पीछे शिफ्ट होगा या नहीं होगा, ये बताइए. Will the overall system shift back and forth if the
Yes,
point
sir.
mass slides from point A to B? Why? Give me the reason. Why will it slide?
Sir, I think there will.
Big.
Go ahead. Anybody?
Sir, I think there should be no
Sir,
displacement of the system.
There should be no displacement of the system. Is there a reason? या फिर आपको
Sir,
लगता
क्योंकि
है
इसके ऊपर एक्सटर्नल फोर्स नहीं लग रहा, वो जो अपने पास पार्टिकल था वो
हाँ.
उसके अंदर ही था और अंदर ही रह गया.
नहीं, क्वेश्चन को अगर आप पढ़ोगे तो क्वेश्चन पहले तो बड़े मास की बात कर रहा है, ब्लॉक मास m इज फ्री टू स्लाइड वगैरह वगैरह, सेंटर ऑफ मास लाइज एट दिस वगैरह वगैरह. अब नाउ पहले तो कुछ नहीं था, पहले यही था सिस्टम, ठीक है, पहले सिस्टम ये था, रेस्ट पे है. अब मैं इसके ऊपर एक छोटा सा पॉइंट मास ऐड कर देता हूं यहां पे ए पॉइंट पे, सो दैट ये पॉइंट मास स्लाइड करके यहां तक पहुंचेगा पॉइंट बी तक. तो सवाल ये है कि ए से बी तक जब जाएगा तो बड़े मास का कोई डिस्प्लेसमेंट होगा क्या आगे पीछे, ये सवाल है. आपको क्या लगता है?
सर ये जो छोटा मास है, जब हम इसे लेके आएंगे तो पहले जो हमारा सेंटर ऑफ मास था वो तो डिस्प्लेस हो जाएगा, मतलब कोई और नया सेंटर ऑफ मास आ जाएगा. फिर
नहीं,
अगर
सेंटर
ये
ऑफ मास,
चलेगा,
चलो सेंटर ऑफ मास डिस्प्लेस होगा, लेकिन ये तो पहले रेस्ट पे था ना. जब ये पॉइंट मास हमने
यस
ऐड
यस सर,
करा तो ये भी रेस्ट पे ही हुआ ना.
यस सर, लेकिन जब ये पॉइंट मास जैसे ग्रेविटी की वजह से नीचे जाएगा
हाँ,
और जब ये चलेगा तो उसकी जो वो है, क्या नाम है, पोजीशन है, वो चेंज होगी. अगर उसकी चेंज हो रही है तो नेसेसरीली फिर बड़े मास की भी चेंज होनी चाहिए,
क्यों,
तभी वो
लॉजिक
प्रिजर्व कर पाएंगे. सर
ताकि
क्योंकि
तो
ये
लॉजिक
ओरिजिनली रेस्ट पे है, सर ओरिजिनली रेस्ट पे है, इसलिए तो उसका सेंटर ऑफ मास उसी जगह रहना चाहिए जहां पर वो है.
हम्म.
Sir, or we can say that the small mass is experiencing gravity and also the normal force due to the contact surface and normal force is in the mg. So the normal force, the big block or mass is giving normal force. Also, the same normal force is coming to the big block due to the internal interaction. So that way it can move back and forth. It is experiencing a force.
But the normal force direction is continuously changing na, so it's difficult to make an analysis like that, don't you think? Normal force का direction तो change हो रहा ना, पहले
Yes.
normal force इधर है, थोड़ी देर बाद इधर होगा, so the normal force itself is continuously changing in direction.
But we are not calculating it with respect to normal force. We are just calculating with respect to center of mass position. Because it will remain constant.
Okay, but
Yes,
जैसा
to
कि
solve
आपने,
this problem.
yes, you only said that there is gravity, right? But I said that center of mass will remain a constant only if in the absence of any external force. So how do you explain that? There is external force. Gravity is there.
No. Yeah. But sir, if we exclude gravity, that the mass is executing just circular motion, so they're needed circular acceleration. So
No,
they're
I'm not
all
saying
internal force.
I'm not saying exclude gravity. I'm saying that the logic is center of mass will remain a constant in the absence of external forces. But यहाँ पे there are external forces. So
Sir,
how do
but sir,
you conclude?
gravity is acting along the y-axis, but we are considered with the x-axis position of the center of mass, so we don't need to worry about that.
Yes, correct, very good. That is what I was looking for. So as जैसा कि मैंने थोड़ी देर पहले आपको बताया, so these conclusions are relevant in every single individual axis. So if there is a force along a specific direction in this particular direction, so then we cannot conclude that the center of mass will be a constant in this direction. So हम y axis में conclude नहीं कर सकते. We cannot make any conclusions about the center of mass being constant along the y axis because there is a force along the y axis, which is the gravitational force. But there is no force along the x-axis. Fx is equal to 0. And because there is no force along the x-axis, therefore, the overall center of mass of the combined system will be a constant during the entire process of motion. So both the bodies will keep on moving so that the overall center of mass remains a constant of motion with respect to time. That is the basic concept here. Okay? इस concept को use करेंगे तो we can easily solve it. Not a problem. क्या आप लोग सॉल्व करना चाहोगे एक बार खुद से ट्राई करना चाहोगे या यू वांट मी टू स्टार्ट
यस सर, यस।
एक बार ट्राई कीजिए लेट मी गिव यू अ कपल ऑफ ऑप्शंस यू कैन ट्राई एंड दिस इज आल्सो बाय द वे क्वेश्चन फ्रॉम जैम राइट सो give it a try see if you can solve it
सर यहाँ पे जो अपने पास एम मास है वो उसके ऊपर फोर्स नहीं लगाएगा वॉल के ऊपर?
हाँ लगाइए ना
फिर सर हॉरिजेंटल डायरेक्शन में भी तो फोर्स लगा उसके ऊपर, मास कैपिटल एम के
हाँ
ऊपर।
हाँ फिर व्हाट इज द कंक्लूजन फोर्स तो है
तो सर
इंटरनल
वही
इंटरेक्शन तो है ना इंटरनल इंटरेक्शन तो है
यस सर।
बट उसके बेसिस पे हमारा क्या कंक्लूजन है फोर्स को
तो सर
यूज
वी आर ओनली टॉकिंग अबाउट एक्सटर्नल फोर्सेस।
We are only talking about external forces.
ओके
Yes,
सर,
correct. मतलब जैसा मैंने
ओके सर,
स्टार्टिंग में बताया था, there are no external forces, right? This is the word.
यस सर,
Internal forces can exist. Internal forces क्या होगा? अगर मास के ऊपर कोई नॉर्मल रिएक्शन लगेगा तो इसके ऊपर भी एक नॉर्मल रिएक्शन लगेगा न्यूटन थर्ड लॉ की वजह से, तो वो तो रहेगा ही. एक्सटर्नल
यस सर,
फोर्स सिर्फ वाई एक्सिस में है, तो वाई एक्सिस में हम सेंटर ऑफ मास को कांस्टेंट नहीं एज्यूम करेंगे, लेकिन एक्स एक्सिस में कोई भी एक्सटर्नल फोर्स नहीं है तो XCM will be a constant. That is the concept. तो इसको यूज करके आप सॉल्व कीजिए. All right, let me check the answers. Vivek S, your answer is not correct. Bamdev, not correct. Kashan, not correct. Check your calculations, everybody. Bamdev, not correct again. See, the concept is very simple. The overall center of mass of the combined system along the x-axis will remain a constant as the motion keeps on happening. So when the small mass is at A, center of mass जहाँ पे होगा, और when the small mass is at B, center of mass जहाँ पे होगा, वो दोनों center of mass एक ही position है. That's it. Based on that, find out x2 minus x1. So x1 is the center of mass of the main object initially, and x2 is the center of mass of the main object at a later stage. But combined system ka center of mass will remain unchanged. Sampurnananda, your answer is correct. Good. Vivek, your second option is correct. Good. Start kare. All right, let's start. All right, guys, let's try to understand the overall motion first. Motion ho kya raha hai? Initially, you have configuration, this one, jahan pe there is a large mass and the point mass at point A. And at a later stage, the configuration is this one, jahan pe the small point mass has moved to the right, point B tak, and as a result, the large mass has shifted to the left. दिख रहा है ना? As a result, the large mass has shifted to the left. So the point mass has shifted to the right and the large mass has shifted to the left to make sure that the center of mass of the entire system remains the same. ठीक है? I hope that it is making sense. ये दोनों डायग्राम ठीक से देखिए. Point mass is at A and large mass is at x1. When the point mass moves to point B, large mass moves to x2. I want to find x1 minus x2. Okay. And why this happens? This happens because the overall center of mass remains a constant. Okay. So let's first define everything. What is the center of mass of the system initially? So, एक एक करके define करते हैं. So when point mass was at A, then let's say I say the center of mass of the overall system when the point mass was at A is equal to what? It is simply equal to the large mass. What is the center of mass of the large mass initially? x1. And the point mass, what is the center of mass of the point mass initially? बताइए. Center of mass of the point mass initially, or the position of the point mass. Huh?
x1 minus r.
x1 minus r, yes, correct. Divided by capital M plus small m. ठीक है? This is the initial center of mass of the system. At a later stage, when point mass reaches location B, then the center of mass of the entire system, when point mass is at B, is equal to the large mass is at a position of x2 and the small mass is at a position of x2 plus r, ठीक है, with respect to the coordinate system upon capital M plus small m. तो यहां पे कॉन्सेप्ट क्या है? Since there are no external forces, along the x-axis, since there are no external forces along the x-axis and system was originally at rest, so the center of mass initially is equal to the center of mass at a later stage. That's it. That's all. I don't have to do anything else. That is all. If I solve this, I'll get the answer. So this becomes capital M x1 plus small m x1 minus r upon capital M plus small m and capital M x2 plus small m x2 plus r upon capital M plus small m. तो ये क्या बन जाएगा? This is simply going to be equal to capital M x1 plus small m x1 minus small m r capital M x2 plus small m x2 plus small m r. ठीक है? तो हमें क्या चाहिए? x1 minus x2 चाहिए. So this is capital M plus small m x1 minus small m r capital M plus small m capital x2 plus small m r. So ये बन जाएगा capital M plus small m x1 minus x2 is equal to 2 small m r, and therefore finally we have capital X1 minus x2 is equal to 2 small m r upon capital M plus small m. That's it. Your answer is option number. कौन सा option number?
सर -2m r आ रहा
सी
है.
सी
अच्छा ये x2 minus
x1
x1
पूछा है.
हाँ x2 minus x1 पूछा है. So x2 minus x1 होगा तो -2mr upon capital M plus small m. That's it. So option number C is the correct answer. See, you just need to understand the concept that is involved, and once you understand the concept that is involved, all the other questions will become easy. So the overall system center of mass initially and the overall system center of mass at a later stage is a constant. इसलिए हमने इन दोनों को equal कर दिया. That's it. Simple concept, simple calculation. But अगर कोई they are doing some question like this for the very first time, तो थोड़ा सा दिक्कत हो सकता है. It is possible that you might think of forces, you might think of this, you might think of that, but the easiest method is to use the concept of center of mass. That is the easiest method. All right, आगे बढ़ते हैं. I'll give you one more question which
Sir,
is similar to this.
is
Bamdev
it a
also
pseudo
correct
force
answer.
acting on the? Is it a pseudo force acting on the mass capital M?
Capital M?
Yes, sir. The capital M is moving. Our system is moving on the left side. So is it a pseudo force that act on it?
It's not a pseudo force, it's a reaction force due to the point mass. Pseudo force की
Okay.
बातें हम तब करेंगे जब अगर हम point mass m का motion study करेंगे ना तब. क्यों? Because point mass m is in a platform which is accelerating. But capital mass M is not in a platform which is accelerating. Do you see the difference? Pseudo force के लिए आपका platform accelerating होना चाहिए. तो small mass का जो platform है वो accelerating है कि नहीं? Yes. Small mass M का platform accelerate कर रहा है कि नहीं? Large mass is accelerating, yes.
Yes, sir.
But
So
capital mass का platform जो है वो तो fixed है ना. तो for small mass
yes,
you
sir.
can think of it like that. All right. एक और सवाल मैं आपको देता हूं which is similar. And just a moment. All right, next question is this one. So here you have a block of mass m 1 kg initially held at a rest on a frictionless surface of a wedge of mass 5 kg. तो आपके पास एक wedge है. आपके पास एक wedge है and the wedge is like 5 kgs and आपके पास है एक 1 kg mass. This is the 1 kg mass. The wedge itself lies on a horizontal frictionless surface. The block now release so that it is allowed to slide down the slope. The block will slide down the slope. है ना? How far down the slope does the block move so that the wedge has moved a distance of 1 centimeter? ठीक है? You're understanding what's happening? A wedge is on a frictionless surface. उसके ऊपर there is a block which is sliding on the inclined plane. So as the block slides on the inclined plane, the wedge will also move to the right. Why? To keep the overall system center of mass constant with time. So how far down the slope does the block move so that the wedge has moved a distance of 1 centimeter? थोड़ा सा टेढ़ा मेढ़ा question है. So be a little careful when you're calculating. Start. This is a little tricky question, so be a little careful, okay? Because it's an inclined motion for one object, it's an inclined motion for the other object, it's a horizontal motion. और एक और चीज ध्यान दीजिए कि if you get a question like this in the examination, I mean, in the class I am giving you a hint, right? Because we are studying center of mass. I have already set up the lecture in such a manner कि मैं एक particular topic को पढ़ा रहा हूँ और उसके अंदर मैंने एक सवाल दिया, तो automatically you know that you want to use this particular concept. लेकिन एग्जाम में अगर आप क्वेश्चंस कर रहे हैं, सडनली ये क्वेश्चन आ जाएगा, तो विल यू बी एबल टू फिगर आउट दैट अच्छा इसको मुझे सेंटर ऑफ मास कॉन्सेप्ट यूज करना है. सो दैट इज ऑल्सो वेरी इंपॉर्टेंट. थिंक ऑफ इट लाइक दैट. इफ यू गेट सम वियर्ड क्वेश्चन लाइक दिस, वुड इट कम टू योर माइंड कि अच्छा मुझे सेंटर ऑफ मास का कॉन्सेप्ट मैं यहाँ यूज कर सकता हूँ या नहीं कर सकता हूँ. ऑलराइट, ट्राई.
Please check the answer I have given you one because I wanna make sure it is correct.
So Bamdev, your answer is not correct. Vivek S, your answer is correct. All right. How far, इस लाइन को ध्यान से पढ़िए. How far down the slope does the block move when the wedge has moved a distance of 1 centimeter?
Sir, just one question.
Yeah.
Instead of using the center of mass concept, if I use the conservation of momentum over here, means if I use the conservation of momentum,
See, but conservation
then
of momentum will give you an idea about velocity, right? We're not
yeah,
interested in
exactly.
velocity.
So, but means
Are we interested in velocity? Because velocity is constantly changing.
I will get the velocity and I can just from the
No, but the
velocity I can
velocity is
find.
not constant now. Do you think that it is accelerating downwards?
But the total momentum is conserved over here, no, sir.
Total momentum is zero.
Yeah, so I can add that and equate to 0.
Yes, but how will you translate it to distance?
If I once have the velocity, then from the velocity I can find the just time means displacement.
No. See, the velocity is not
But
constant.
but
Velocity is
that
changing.
but that's what I did and I got 12.
Okay, can you explain how you did that? So you got
Yeah.
V1 and V2.
Okay. V1 and V2. And
And
if it is capital M and small m, then V2 is having only means V1 is having in x-axis only, no sir. So because
yes, and after that, what do you do? What did you do? You
conservation of
calculated V2 at
momentum.
1 centimeter.
No.
Yeah, but huh.
Means V1 will be derivative of the displacement cos theta plus the displacement of the wedge like xw.
So you integrated it?
Yes, exactly.
Ah, okay, fine. Then it's okay. I
Yeah.
thought you were just doing kinematics. So you integrated
No.
it properly. Then it's okay.
Yes.
Because velocity is variable, so you have to integrate it with respect to the proper limits.
Yeah. Once I got the velocity, they can integrate and find the displacement over.
Then it's okay. Then it's okay.
Yeah.
Yeah, you can do like that also. No problem.
Okay, sir.
Yeah. Kashan, your answer is not correct. थोड़ा सा ट्रिकी क्वेश्चन है गाइस, ध्यान से देखिए. There is an inclined motion happening for the block and horizontal motion happening for the mass wedge. नहीं हो रहा. What about the other students? You can share your answers even if they are not correct. Because these are all jam type of questions. मतलब usually JEST में नहीं आते हैं इस तरह के questions. But jam में तो आ सकते हैं. All jam type
Sir,
of
I
questions.
want to know if my approach is correct or not.
Okay.
Okay, so what I have done is the
Yes.
the wage has moved to 1 semi. So if the initially it was red, so its center of mass is at the center of mass I have put the fx as 0. So if the wedge has moved distance of 1 semi to the right, so then I put the 5 into 1. 1 is for the center of mass moving and plus, and for the small block I have put it is going down the x-axis. So it's horizontally how much it has shift. I have taken it as x. So 1 plus x plus 5 is equal to 0 because I have initially put the center of mass is equal to 0.
But
And
center of
in
mass is
that
0
way,
for the wedge, right? According to your calculation, you have taken the center of mass to be 0 with respect to the wedge, not with respect to the block. You have to have a fixed coordinate system that is common for both the block and the wedge. So you are choosing the origin of the center of origin of the coordinate system to be coinciding with the center of mass of the wedge, but not the block. Are you understanding? You need to have a fixed coordinate system. And with respect to that coordinate system, you calculate the positions of wedge and the block. Are you following?
hello.
Yeah.
Yes, sir. What did you want?
I said that you need to have a fixed coordinate system. And with respect to a fixed coordinate system, you need to measure the positions of the wedge and the block.
Yes, sir, it is fixed. When the block and the wedge was at rest, and I have taken the center of mass of that position at x is equal to 0. So after that, I didn't change it.
No, but the center of mass of the wedge is coinciding with the origin of the coordinate system, right?
The center of mass of wedge and block bind is coinciding with the origin of the coordinate system
Initially. Okay, understood.
initially, and
Okay.
then it got shifted at the right and the left. But
Fine.
in that way, the answer is coming 10.
All right. Okay. I want to point out where you're making the mistake. So you have taken the displacement of the wedge to be 1 centimeter to the right, yes?
Yes.
And
Yes, sir.
you have measured the displacement of the block to the left along the inclined plane.
Horizontally. Horizontally. First, how much it has moved horizontally, then I calculate its length.
Okay, so ultimately you are calculating along the inclined plane. Final answer. 10 centimeter is coming out to be the distance along
Yes,
the
sir.
inclined plane or
Yes.
horizontal? Along the inclined plane?
Along the incline.
Yes, correct. Fine. अब मुझे एक बात
Why
बताइए.
did I make the mistake?
वही मैं एक्सप्लेन कर रहा हूँ. मैं एक्सप्लेन कर रहा हूँ आपको. You have moved, the block has moved 10 centimeter with respect to
Initial coordinate system.
coordinate system.
Yes.
I'm giving you the
Yes.
hint. The block has moved 10 centimeter with respect to coordinate system. लेकिन सवाल में coordinate system के respect में नहीं पूछा है. सवाल में क्या पूछा है? With respect to the wedge पूछा है. The wedge has also moved. Are you getting? So I'll give you an example, a simple example. हम जब airport में जाते हैं, तो there are certain platforms which are moving forward. All right.
Yes.
So if I move 10 centimeter to the left and the platform has moved 1 centimeter to the right, with respect to the platform, how much have I moved to the left? 10 plus 1.
11. 10 plus 1.
That is what you are missing because you calculated correctly but with respect to the coordinate system which is unchanging. But सवाल में coordinate system के respect में नहीं पूछा है, सवाल में
Oh, then it
wedge
is
के
coming.
respect. Yes.
Then it is coming right. 12.
Then it's yes. Understood? Okay. So you have to
Okay, sir.
calculate
Thank you.
with respect to the wedge, because the wedge has also moved. So you have to add it to your final
Yes.
answer. So you see, that is where you can make some mistakes. You can be confident, okay, I got the right answer, but वो छोटा सा एक चीज missing हो जाता है. Anyways. So Kashan, correct answer. Sampurnananda, correct answer. Finally, let's start. Okay. थोड़ा सा tricky question है ये, because it involves so many things. It involves inclined motion. It involves, you know, calculating the final answer with respect to a moving platform. So when you sort of combine all these things together, only then you end up getting the correct answer. All right, let's look at this. See, the choice of coordinate system is yours. You can choose the coordinate system. मैं इस तरह से ले रहा हूं. Okay, this is what I am doing. I am choosing a fixed coordinate system. All right. So what is happening here? Let's try to understand. So in this scenario, what is happening? The block slides downwards. As a result, the wedge moves to the right. So I am only looking at the initial and the final configuration. Initially block A में था और finally block B में है. Okay, even though I want to calculate the distance along the inclined plane, पहले मैं horizontal distance के ऊपर focus करता हूँ. ठीक है. So what is the concept here? The concept is very simple. Since there are no forces, along the x-axis, the x center of mass of the system will be at rest. ठीक है, बात खत्म. All right, now what we do is, as the block move forwards, as the block slides down the inclined plane of wedge, the wedge moves 1 centimeter to right and block moves, I am saying, del centimeter to left horizontally. Okay, अब हम calculations को करते हैं. So what is the initial center of mass when block was at A, and whatever is the initial final center of mass when block is at B is exactly going to be equal. तो यहाँ पे क्या होगा? So initially the position of the wedge is 5 kg times x1 and position of the block is 1 kg times x2. ठीक है, 5 plus 1 initially. At a later stage, the wedge gets shifted by 1 centimeter. So ये बन जाता है 5 x1 plus 1, and the block gets shifted to the left by del centimeters in the horizontal direction. So 1 x2 minus del, 5 plus 1. That's it. This is the concept. Now we are going to solve it. 5x1 plus 1x2 is equal to 5x1 plus 5 plus x2 minus del. So यहाँ पे 5x1 cancel. x2 cancel. So what do we get? Del is equal to 5 centimeter. So that means the block has shifted horizontally to the left by 5 centimeters. ठीक है? लेकिन this is not the answer. Why? Because this is a distance with respect to the coordinate system, but I am interested in the distance with respect to the platform, which is the wedge. So del is equal to 5 centimeter is the distance traveled by block with respect to coordinate system. But with respect to wedge, distance traveled is how much? ये important point है. Distance traveled horizontally is, with respect to wedge, distance traveled horizontally is 5 centimeter plus 1 centimeter. Because a wedge has shifted 1 centimeter to the right and the block has shifted 5
Sir?
centimeter to the left, overall shift with respect to the wedge is 6 centimeter. हाँ जी बताइए.
सर यहाँ पे एक क्वेश्चन था कि इनके बीच में थोड़ा सा डिस्टेंस ये भी है ना x2 माइनस x1, तो वो भी जुड़ेगा ना साथ में, मतलब जुड़ना चाहिए. 6
नहीं वो तो
प्लस
कैंसिल हो गया ना यहाँ पे, कैंसिल हो गया ना. x1 और x2 इंडिपेंडेंट है ना. x1 इज द पोजीशन ऑफ द वेज एंड x2 इज द पोजीशन ऑफ द ब्लॉक. वो तो कोई रिलेशन है ही नहीं ना सवाल के अकॉर्डिंग. इनिशियल पोजीशन ऑफ द वेज इज x1, इनिशियल पोजीशन ऑफ द ब्लॉक इज x2. सवाल में तो कोई हमें रिलेशन दिया नहीं है कि कहां पे पोजीशनड है, समझ रहे हो. और फॉर्चुनेटली इक्वेशन में कैंसल आउट हो गया तो उनकी जरूरत ही नहीं पड़ी. हमको तो सिर्फ डेल चाहिए ना. डेल इज द शिफ्ट इन द पोजीशन ऑफ द ब्लॉक. हमको तो वही चाहिए बस, तो वो तो मिल ही गया. आर यू फॉलोइंग?
यस
सो हाँ, इसलिए अभी x2 और x2 इस क्वेश्चन में x1 x2 की जरूरत नहीं है. मतलब ये अकॉर्डिंग हमें सिर्फ डेल की जरूरत है. तो डेल मिल गया विथ रेस्पेक्ट टू वेज, इट इज 6 सेंटीमीटर. बट यहां पे एक और ट्विस्ट है. वो ट्विस्ट क्या है कि डेल इज द हॉराइजेंटल डिस्टेंस, बट यहां पे पूछा है हाउ फार डाउन द स्लोप. मतलब दे आर आस्किंग अस द डिस्टेंस अलोंग द इंक्लाइन प्लेन, not the horizontal distance. So now we also have to calculate along the inclined plane. तो ये दोनों पॉइंट जो है बहुत ही इंपॉर्टेंट है. आप हो सकता है यू विल मिस दिस पॉइंट और द नेक्स्ट पॉइंट. तो दोनों पॉइंट जो है इनकॉर्पोरेट हमें करना पड़ेगा to get the final correct answer. So distance traveled along the slope और inclined plane क्या होगा? इज इक्वल टू 6 सेंटीमीटर अपॉन इंक्लाइन प्लेन का एंगल क्या है? cos 60 डिग्री हो जाएगा. cos 60 डिग्री. सो दिस इज इक्वल टू 2 times 6 सेंटीमीटर इज इक्वल टू 12 सेंटीमीटर. दैट्स इट. दैट्स द आंसर. 12 सेंटीमीटर्स. देखिए, if you look at the PYQs, if you look at practice problems, there are many questions like these. Okay, मैं कोशिश ये करता हूं कि क्लास के दौरान एटलीस्ट एक या दो इंटरेस्टिंग सवाल अच्छे से डिस्कस कर दूं, so that you can get an understanding of the concept involved. Because once you get an understanding of the concept involved, you can use that concept in other questions in a similar manner. ठीक है? तो yeah, again, you can go and practice, but most of these kinds of questions will have similar concepts involved. एक और question करते हैं. We have 10 minutes left. So let me give you a little bit of a different kind of a question. Slightly different, that involves center of mass which is not at rest. अभी तक हम जो क्वेश्चन कर रहे थे in all those questions, the center of mass was initially at rest. But what if the center of mass is initially not at rest, but it is in some sort of a motion? तो क्या होगा, है ना? तब कैसे सिचुएशन होगा? So let us look at this particular question. So a projectile is fired at a speed of 100 meter per second at an angle of 37 degree above the horizontal. At the highest point, the projectile breaks into two parts of mass ratio 1/3, smaller coming to rest immediately. Find the distance from the launching point to the point where the heavier piece lands. समझ रहे हो? एक projectile है जिसको फेंका गया with a certain speed, a certain angle. The moment it reaches the highest point, it breaks into two. Think of it like a bomb, like a cracker or something like that. वो टूट जाता है दो पीसेस में, और टूटते ही जो छोटा मास है वो इमीडिएटली रेस्ट पे आ जाता है, और जो बड़ा मास है वो फिर इट कंटिन्यूज इन इट्स ओन ट्रैजेक्टरी. सो व्हाट इज द डिस्टेंस फ्रॉम द लॉन्चिंग पॉइंट टू द पॉइंट विद अ हेवियर पीस लैंड्स? खुद से एक बार ट्राई कीजिए. लेट मी सी इफ यू कैन कम अप विद द आंसर. उसके बाद मैं हिंट दूंगा आपको. सबसे पहले तो ये बताइए, द हेवियर मास. Bamdev, your answer is correct. Very good. The heavier mass, is it going to create some different trajectory as opposed to the initial trajectory?
Yes, sir.
Why?
Because the heavier mass is First, if it was together, it will be just a simple parabolic path. But if it is different, so to keep the center of mass constant, it will move in a different path because the smaller mass has already stopped. Then it will create a different path from the highest point, make the center of mass constant.
Yes, correct. So हमने अभी जो क्वेश्चंस करे थे, we assume that the overall system initially was at rest. But मैंने स्टार्टिंग में आप लोग को बताया था that if the external forces are zero, then the velocity of the center of mass is a constant. So if you look at the projectile's motion will replicate, the center of mass motion will replicate the motion of the projectile, because the center of mass velocity is a constant of motion. तो उसको constant रखने के लिए the second particle will have a different trajectory, so that the final configuration is such that the center of mass position is same as the position of the initial projectile once it completes the motion. मैं आपको hint भी दे देता हूं. So you can think of like in this particular diagram. So if you look at this diagram, हो सकता है कि it's not very intuitive, so think about it a little bit. So you throw a projectile up, ऊपर पहुंचते ही यहाँ पे it breaks into two parts. One part drops, the other part will continue in a separate journey, so that the center of mass motion will be the original projectile motion. That's it. दोनों का जो center of mass है ना, that will replicate the original projectile motion. That's it. That is the concept that can be used here. When moving objects split into multiple particles, the original trajectory is followed by the center of mass of those particles. ठीक है, तो हमें क्या पूछा गया है? What is the distance from the launching point to the point where the heavier piece lands? So before we calculate the heavier piece position, which is x, can I calculate the final point of the center of mass? Kashan, Vivek S, correct answer. So the final position of the center of mass is nothing but the range. I can calculate the range. So range R is equal to u square sine 2 theta upon g, which is equal to speed is 100 meter per second square, sine 74 degrees upon g. इसको कैलकुलेट करोगे ना, कितना आता है ये वाला, बताइए. What is the answer to this?
24/5 into 10 to the power cube.
फाइनल आंसर कितना आता है?
सर 961.28.
960 लिख देते हैं अप्रॉक्स. 960 लिख देते हैं क्योंकि
961.28.
हाँ, अप्रॉक्स 960 लिख देते हैं यहाँ पे.
सर मीटर मीटर
हाँ मीटर. So this is the final position of the center of mass. So this is nothing but the position of the center of mass finally. So what is the center of mass? The center of mass is simply equal to the first mass times the position of the first particle. वो कितना होगा? वो बीच में ही रुक गया था तो 960/2 होगा. और द सेकेंड मास विच इज 3 टाइम्स, इसका पोजीशन हमें नहीं पता तो x लिख देते हैं, डिवाइडेड बाय m + 3m. सो दिस इज नथिंग बट xcm is equal to 960. This is equal to 480m plus 3mx upon 4m. So therefore this becomes 4 into 0, 24, 2, 36, 37, 38 meter mass is equal to 480 mass plus 3mx. तो mass तो यही कैंसिल हो गया and x is equal to 3840 minus 480 upon 3. So 3840 is 3400. 38404, 3360 upon 3 is equal to 1120 meters. That's it. The answer is option number A. Answer is option number A. So you see what's happening here, that most of these questions you need not apply force equations. You can also avoid applying conservation of momentum or other kinds of principles. You can simply apply the concept of center of mass of a isolated system. ठीक है, ये क्वेश्चन इससे पहले जो भी दोनों क्वेश्चंस करे थे, इसमें आप अलग कॉन्सेप्ट भी लगा सकते हो. आप फोर्सेस के पॉइंट ऑफ व्यू से भी देख सकते हो, आप कोई कंजर्वेशन प्रिंसिपल के पॉइंट ऑफ व्यू से भी देख सकते हो, वर्क डन के पॉइंट ऑफ व्यू से भी देख सकते हो. बट आई थिंक दैट द इजीएस्ट मेथड इज व्हेन यू लुक एट सेंटर ऑफ मास सिस्टम. हम कब लगा सकते हैं सेंटर ऑफ मास कॉन्सेप्ट? जब external force along a particular direction is 0. That's it. If external force along a particular direction is 0, center of mass will be a sort of time derivative will be a constant of motion. तो अगर initially रेस्ट पे था, finally भी रेस्ट पे रहेगा. I will share some homework problems with this PDF. Please solve it, all of them. Usually center of mass से related questions एक आ ही जाता है, and they are usually easy questions. So if you practice this particular topic, I don't think you should find it very difficult. It's actually a relatively easy topic. In the next class, we will study an important topic of potential energy analysis. So potential energy analysis is an important topic, very common topic. हम अगले क्लास में वो पढ़ेंगे, ठीक है? If you have any doubts, we can discuss. Vivek, yes, I use conservation of momentum in this question. Yeah, perfectly fine. I mean, there are other methods that you can do it. Sampurna, the correct answer. There are other methods in which you can do it. Not a problem at all. In the final examination, you have access to so many different techniques to solve a given question. So if you're able to solve it using any other method, that's also perfectly fine.